At the heart of Campbell's Co Gen system is the combustion gas turbine. This one is manufactured by Solar Turbines out of San Diego, California. It's a part of the broader Caterpillar family of companies. A gas turbine really is similar to what sits under the wing of a major commercial airliner. It's a jet engine, really. So in this case, the industrial gas turbine works basically on sucking in a whole bunch of air. So it pulls in a big amount of air. That air is then compressed in the compressor section of the turbine. Then it makes its way into the combustion section where fuel is added and we have a combustion process. And then as a result, that gas is expanded across the power turbine, and that's what makes the electricity, and then the exhaust gas goes to the heat recovery steam generator. So you're sucking in a lot of air, you're burning fuel and you're heating up that air, and the expansion drives the energy generation. A gas turbine like the one here at Campbell's is really well suited for anybody with a large heat load in various different forms. So whether they need a lot of steam, whether they need a lot of chilled water year-round, whether they need a lot of hot air for drying processes, anybody who needs a lot of energy, who's currently consuming a lot of natural gas to do their process is a good fit. In addition, plants or facilities or campuses that have a continuous electrical load anywhere between 3 megawatts and 5 megawatts, this is also a nice fit electrically. So we want to find sites that have that balance of both electrical needs between 3 and 5 megawatts and then thermal needs that are pretty sizable. Some of the unique features of this particular gas turbine is, for example, the emissions control. It has what Solar Turbines calls a solo NOx emissions control. It's a dry, low emissions control technology that brings the ppm of the NOx emissions particularly, but also sulfur and carbon monoxide, brings that down in the emissions stream. And so any jurisdiction that has really tight regulations for emissions, a machine like this with the solo NOx control really helps meet the emissions requirements or the permitting requirements. It has a Turbotronics 5 control system, which provides a robust controller for the turbine for synchronization with the grid. This particular system is equipped with a combustion air inlet cooling system, and so as air is drawn in on a hot summer day, it's cooled, and the cooler the air, the denser the air, the more power we get out of the gas turbine. And so that's critical here as well, to make more power on a hot summer day for Campbell's or for any site to have more power available. That's also very important. This gas turbine has been running for 3 years now. It has about 22,000 operating hours on it. It is being serviced under a full comprehensive long-term service agreement with Solar Turbines. That is still in effect, and the accrual for an overhaul at year 4 or year 5 has been made year after year, and so the system has been well maintained. It's really part of a broader cogeneration system. It has all the ductwork, all the lube oil coolers, all the MCCs, all the VFDs, all of that is part of this complete package. The system has been designed, whether it be the gas turbine package or the transformer or all of the ancillary systems, have been designed that at that overhaul point, it also could go to a larger machine. So instead of 4.5 megawatts, you could put in a 5.5 megawatt machine and make more power out of this gas turbine. So the exhaust gas that leaves the gas turbine then goes into a heat recovery steam generator, which is very similar to a steam boiler making steam for a process. In this case, it's a Cleaver-Brooks heat recovery steam generator, or HRSG. It was manufactured in Nebraska as part of what used to be Energy Recovery International, now Cleaver-Brooks. It's rated at 90,000 pounds an hour of steam. It makes steam at 170 psig, saturated steam. It's equipped with a NatCom duct burner, and so the unfired rating, if there was no gas being burned in the duct burner, is about 25,000 pounds an hour, and then the duct burner will increase the gas temperature such that we can get up to 90,000 pounds an hour of steam out of the system. It's also equipped with a feedwater economizer that makes the overall system more efficient, and then it has all the boiler trim and feedwater control, natural gas control, steam metering, all the bells and whistles that go around it that contribute to a highly reliable and highly efficient system. We have a Vilter fuel gas booster compressor here. It's a single screw machine. Vilter is part of the broader Emerson family of companies, and it's been a very reliable unit. It's kind of one of the most critical, because if the gas is not at pressure, the turbine won't run and nothing else will happen. So the gas compressor is really critical. It's been very reliable. There's a comprehensive maintenance program as part of it, but its main function is to bring pipeline gas from 30 psig to 250 psig, and it does that reliably day in and day out. So here we have the generator making power at 13.8 kilovolts, 13,800 volts. So after the power leaves the generator, it goes into what we call the 15 kV class of switchgear. There's a metering cell in there, and then there's a generator breaker in there. That generator breaker provides protection for the generator. If something were to happen out on the grid, that breaker would protect the generator from anything untoward happening to it. And then once we leave that generator breaker, we have to step up the power for distribution throughout the Campbell's site. And so we have a 5 MVA transformer that steps the power from 13.8 kV to 27.6 kV. That's an oil-filled transformer. It's rated for outdoor installation. It can be equipped with fans if the system needs to be upgraded in the future. And so that brings the power to 27.6 kilovolts, and then that's distributed on 27.6 switchgear, which is of a 38 kV class. That gear here is interesting. It's outdoor rated gear, and it has a breaker in it for transformer protection. It has a breaker in it for islanding the plant. And so in the event of a utility trip or some other event on the grid, that breaker in that 27.6 switchgear can automatically island the whole campus here at Campbell's, and they continue to ride through any event. And so that's all integral to the 27.6 switchgear. In addition, all the switchgear, all the elements have protection and control. So there's a bunch of Schweitzer relays for protection of the generator, protection of the utility, protection of the transformer. So that whole electrical system is a comprehensive package that fits nicely with this gas turbine and with this site, and would fit the needs of many other sites as well. Within the Co Gen plant, each big piece of equipment, the turbine, the heat recovery steam generator, the gas compressor, they all have their own dedicated controller, but like any good team, they have to work together. And so to make them work together, we have a balance of plant supervisory control system. We have the guts of it are right here, and there's a user interface in the control room. And it really brings together all the elements of the system, including any balance of plant meters or control valves or any other elements. And it provides the operator a real interface in terms of what's happening in the system. It allows the operator to control certain elements, whether that be electrically, whether they're going to island, or how much steam they want to make. It allows them to decide, are they going to make power, are they going to buy power. So it's really the heart of the control system and the heart of the system from an operations interface perspective. It also allows load shedding. So this plant is equipped with load shedding, so that if they have to get rid of load in an islanding event, the system will automatically shed some non-critical loads so that the turbine can meet the critical load of the plant in the event of a grid failure, for example. After the implementation of the Co Gen, Campbell's put in a reverse osmosis system to treat water that they're using elsewhere in the process and make it suitable for boiler feed water. This really allowed them to drive a lot of savings in terms of their water use and their water disposal costs, and it made the system overall more efficient. And so that system provides them all the feed water they need for the boilers, and it's coming from a recaptured water source. Additionally, to drive a more efficient system, we tied into the existing condensing economizer here. It's rated for about 6 million BTUs per hour of heat recovery, and it takes the hot exhaust gas, what energy is left in it after the boiler, it takes it out and draws out additional energy and makes hot water for the heating process of the soup, but also space heating and things like that. So it's a neat add-on to a Co Gen that drives even more overall system efficiency, causes more natural gas savings, and drives more money back into the operation.